Conscious, A Brief Guide to the Fundamental Mystery of the Mind, by Annika Harris. This is the author. For Sam, Emma, and Violet. 1. A mystery hiding in plain sight. Our experience of consciousness is so intrinsic to who we are, we rarely notice that something mysterious is going on. Consciousness is experience itself, and it is therefore easy to miss the profound question staring us in the face in each moment. Why would any collection of matter in the universe be conscious? We look right past the mystery as if the existence of consciousness were obvious or an inevitable result of complex life. But when we look more closely, we find that it is one of the strangest aspects of reality. Thinking about consciousness can spark the same kind of pleasure we get from contemplating the nature of time or the origin of matter, invoking a deep curiosity about ourselves and the world around us. I remember looking up at the sky when I was young and realizing that my usual sense of being down on the ground with the sky above me wasn't an entirely accurate perception. I was intrigued by the fact that even though I had learned that gravity pulls us toward the Earth as we orbit the sun, and that there is no real up and down, my feeling of being down on the ground below the sky had remained unchanged. To shift my perspective, I would sometimes lie outside with my arms and legs outstretched and take in as much of the sky and horizon as possible. Attempting to break free of the familiar feeling of being down here with the moon and stars above me, I would relax all my muscles, surrendering to the force holding me tightly to the surface of our planet, and focus on the truth of my situation. I'm floating around the universe on this giant sphere, suspended here by gravity and going for a ride. Lying there, I could sense that I was in fact looking out at the sky rather than up. The delight I experienced came from temporarily silencing a false intuition and glimpsing a deeper truth. Being on the Earth doesn't separate us from the rest of the universe. Indeed, we are and have always been in outer space. This book is devoted to shaking up our everyday assumptions about the world we live in. Some facts are so important and so counterintuitive. Matter is mostly made up of empty space. The Earth is a spinning sphere in one of billions of solar systems in our galaxy. Microscopic organisms cause disease, and so on, that we need to recall them again and again until they finally permeate our culture and become the foundation for new thinking. The fundamental mysteriousness of consciousness, a subject deeply perplexing to philosophers and scientists alike, holds a special place among such facts. My goal in writing this book is to pass along the exhilaration that comes from discovering just how surprising consciousness is. Before posing any questions about consciousness, we must determine what we are talking about in the first place. People use the word in a variety of ways, for example, in referring to a state of wakefulness, a sense of selfhood, or the capacity for self-reflection. But when we want to single out the mysterious quality at the heart of consciousness, it's important to narrow in on what makes it unique. The most basic definition of consciousness is that given by the philosopher Thomas Nagel in his famous essay, What Is It Like to Be a Bat? And it is how I use the word throughout this book. The essence of Nagel's explanation runs as follows. An organism is conscious if there is something that it is like to be that organism. In other words, consciousness is what we're referring to when we talk about experience in its most basic form. Is it like something to be you in this moment? Presumably, your answer is yes. Is it like something to be the chair you're sitting on? Your answer will most likely be an equally definitive no. It's this simple difference, whether there is an experience present or not, which we can all use as a reference point, that constitutes what I mean by the word consciousness. Is it like something to be a grain of sand, a bacterium, an oak tree, a worm, an ant, a mouse, a dog? At some point along the spectrum, the answer is yes, and the great mystery lies in why the lights turn on for some collections of matter in the universe. We can even wonder, at what point in the development of a human being does consciousness flicker into existence? Imagine a human blastocyst just a few days old, consisting of only about 200 cells. We assume there's probably nothing it is like to be this microscopic collection of cells. But over time, these cells multiply and slowly become a human baby with a human brain, able to detect changes in light and recognize its mother's voice, even while in the womb. And unlike a computer, which can also detect light and recognize voices, this processing is accompanied by an experience of light and sound. At whatever point in the development of a baby's brain your intuition tells you, okay, now an experience is being had in there, the mystery lies in the transition. First, as far as consciousness is concerned, there is nothing, and then suddenly, magically, at just the right moment, something. However minimal that initial something is, experience apparently ignites in the inanimate world, materializing out of the darkness. After all, an infant is composed of particles indistinguishable from those swirling around in the sun. The particles that compose your body were once the ingredients of countless stars in our universe's past. They traveled for billions of years to land here, in this particular configuration that is you, and are now reading this book. Imagine following the life of those particles from their first appearance in space-time to the very moment they became arranged in such a way as to start experiencing something. The philosopher Rebecca Goldstein paints a wonderfully clear and playful portrait of the mystery. Sure, consciousness is a matter of matter. What else could it be, since that's what we are? But still, the fact that some hunks of matter have an inner life is unlike any other properties of matter we have yet encountered, much less accounted for. The laws of matter and motion can produce this, all this. Suddenly matter wakes up and takes in the world. The moment matter becomes conscious seems at least as mysterious as the moment matter and energy sprang into existence in the first place. The mystery of consciousness rivals one of the greatest conundrums ever to bend human thought. How could something appear out of nothing? Likewise, how does felt experience arise out of non-sentient matter? The Australian philosopher David Chalmers famously termed this the hard problem of consciousness. Unlike the easy problems of explaining animal behavior or understanding which processes in the brain give rise to which functions, the hard problem lies in understanding why some of these physical processes have an experience associated with them at all. Why do certain configurations of matter cause that matter to light up with awareness? 2. Intuitions and illusions. Now that we have a working definition of consciousness and the mystery it entails, we can start chipping away at some common intuitions. In large part, our intuitions have been shaped by natural selection to quickly provide life-saving information, and these evolved intuitions can still serve us in modern life. For example, we have the ability to unconsciously perceive elements in our environment in threatening situations that in turn deliver an almost instantaneous assessment of danger, such as an intuition that we shouldn't get into an elevator with someone, even though we can't put our finger on why. Your brain is often processing helpful cues you may not be aware of in the moment. The other person who is getting into the elevator is flushed or has dilated pupils. Both are signals that he is adrenalized and about to act violently. Or the door to the building, which is usually locked, has been left ajar. We can know that a situation is dangerous without having any idea how or why we know it. Our intuitions are also shaped through learning, culture, and other environmental factors. We sometimes have useful intuitions about life decisions, such as which apartment to rent, born of relevant information that our brain has acquired and taken into account through unconscious processes. In fact, research suggests that our gut feelings are more reliable in many situations than the fruits of conscious reasoning. But our gut can deceive us as well, and false intuitions can arise in any number of ways, especially in domains of understanding, such as science and philosophy, that evolution could never have foreseen. Consider probability and statistics, where our intuitions are notoriously unreliable. Many of us are nervous flyers, despite the fact that statistically we would need to fly every day for about 55,000 years before being involved in a fatal plane crash. And it's worth mentioning that although people don't commonly have panic attacks when getting behind the wheel in preparation for a trip to the grocery store, one's safety on such trips is actually less secure by many orders of magnitude than while flying. We can barely square our intuitions with some of the most basic scientific facts. The Earth seemed flat to us until breakthroughs in celestial observations revealed otherwise. And in some areas of study, such as quantum physics, our intuitions are not only useless, but are an outright obstacle to progress. An intuition is simply the powerful sense that something is true, without our having an awareness or an understanding of the reasons behind this feeling. It may or may not represent something true about the world. In this chapter, we will consider our intuitions regarding how we judge whether or not something is conscious, and will discover that the seemingly obvious answers sometimes fall apart upon closer inspection. I like to begin this exploration with two questions that at first glance appear deceptively simple to answer. Note the responses that first occur to you, and keep them in mind as we explore some typical intuitions and illusions. 1. In a system that we know has conscious experiences, the human brain, what evidence of consciousness can we detect from the outside? 2. Is consciousness essential to our behavior? These two questions overlap in important ways, but it's informative to address them separately. Consider first that it's possible for conscious experience to exist without any outward expression at all, at least in a brain. A striking example of this is the neurological condition called locked-in syndrome, in which virtually one's entire body is paralyzed, but consciousness is fully intact. This condition was made famous by Jean-Dominique Bauby, the late editor-in-chief of French Elle, who ingeniously devised a way to write about his personal story of being locked in. After a stroke left him paralyzed, Bauby retained only the ability to blink his left eye. Amazingly, his caretakers noticed his efforts to communicate, and over time they developed a method whereby he could spell out words through a pattern of blinks, thus revealing the full scope of his conscious life. He describes this harrowing experience in his 1997 memoir, The Diving Bell and the Butterfly, which he wrote in about 200,000 blinks. Of course, we may assume that his consciousness would not have been changed whatsoever if his left eyelid had succumbed to the paralysis as well. And without this mobility, there would have been absolutely no way for him to communicate that he was fully conscious. Another example of bodily imprisonment is a condition called anesthesia awareness, in which a patient given a general anesthetic for a surgical procedure experiences only the paralysis without losing consciousness. People in this condition must live out the nightmare of feeling every aspect of a medical procedure, sometimes as drastic as the removal of an organ, without the ability to move or communicate that they are fully awake and experiencing pain. This and the previous example seem to come straight out of a horror movie, but we can imagine other, less disturbing instances in which a conscious mind might lack a mode of expression. Scenarios involving artificial intelligence, AI, for example, in which an advanced system becomes conscious but has no way of convincingly communicating this to us. But one thing is certain. It's possible for a vivid experience of consciousness to exist, undetected from the outside. Now let's go back to the first question and ask ourselves, what might qualify as evidence of consciousness? For the most part, we believe we can determine whether or not an organism is conscious by examining its behavior. Here is a simple assumption most of us make, in line with our intuitions, that we can use as a starting point. People are conscious, plants are not conscious. Most of us feel strongly that this statement is correct, and there are good scientific reasons for believing that it is. We assume that consciousness does not exist in the absence of a brain or a central nervous system. But what evidence or behavior can we observe to support this claim about the relative experience of human beings and plants? Consider the types of behavior we usually attribute to conscious life. such as reacting to physical harm or caring for others. Research reveals that plants do both of these things in complex ways, though of course we conclude that they do so without feeling pain or love, i.e. without consciousness. But some behaviors of people and plants are so alike that this in fact poses a challenge to our using certain behavior as evidence of conscious experience. In his book, What a Plant Knows, A Field Guide to the Senses, Daniel Shamovitz describes in fascinating detail how the stimulation of a plant, by touch, light, heat, etc., can cause reactions similar to those in animals under analogous conditions. Plants can sense their environment through touch and can detect many aspects of their surroundings, including temperature, by other modes. It's actually quite common for plants to react to touch. A vine will increase its rate and change its direction of growth when it senses an object nearby to wrap itself around. And the infamous Venus flytrap can distinguish between a heavy rain or strong gust of wind, which do not cause its blades to close, and the tentative incursions of a nutritious beetle or frog, which will make them snap shut in 1/10 of a second. Shamovitz explains how the stimulation of a plant cell causes cellular changes that result in an electrical signal, similar to the reaction caused by the stimulation of nerve cells in animals. And just like in animals, this signal can propagate from cell to cell, and it involves the coordinated function of ion channels, including potassium, calcium, calmodulin, and other plant components. He also describes some of the shared mechanisms between plants and animals down to the level of DNA. In his research, Shamovitz discovered which genes are responsible for a plant's ability to determine whether it's in the dark or the light, and these genes, it turns out, are also part of human DNA. In animals, these same genes regulate responses to light and are involved in the timing of cell division, the axonal growth of neurons, and the proper functioning of the immune system. Analogous mechanisms exist in plants for detecting sounds, scents, and location, and even for forming memories. In an interview with Scientific American, Shamovitz describes how different types of memory play a role in plant behavior. If memory entails forming the memory, encoding information, retaining the memory, storing information, and recalling the memory, retrieving information, then plants definitely remember. For example, a Venus flytrap needs to have 2 of the hairs on its leaves touched by a bug in order to shut, so it remembers that the first one has been touched. Wheat seedlings remember that they've gone through winter before they start to flower and make seeds. And some stressed plants give rise to progeny that are more resistant to the same stress, a type of transgenerational memory that's also been recently shown in animals. The ecologist Suzanne Simard conducts research in forest ecology, and her work has produced breakthroughs in our understanding of inter-tree communication. In a 2016 TED Talk, she described the thrill of uncovering the interdependence of 2 tree species in her research on mycorrhizal networks, elaborate underground networks of fungi that connect individual plants and transfer water, carbon, nitrogen, and other nutrients and minerals. Simard was studying the levels of carbon in 2 species of tree, the Douglas fir and the paper birch, when she discovered that the 2 species were engaged in a lively 2-way conversation. In the summer months, when the fir needed more carbon, the birch sent more carbon to the fir. At other times, when the fir was still growing but the birch needed more carbon because it was leafless, the fir sent more carbon to the birch, revealing that the 2 species were in fact interdependent. Equally surprising were the results of further research led by Simard, showing that Douglas fir mother trees were able to distinguish between their own kin and a neighboring stranger's seedlings. Simard found that the mother trees colonized their kin with bigger mycorrhizal networks, sending them more carbon below ground. The mother trees also reduced their own root competition to make room for their kids, and when injured or dying, sent messages through carbon and communicated other defense signals to their kin seedlings, increasing the seedling's resistance to local environmental stresses. Likewise, by spreading toxins through underground fungal networks, plants are also able to fight off threatening species. Because of the vast interconnections and functions of these mycorrhizal networks, they have been referred to as Earth's natural internet. Still, we can easily imagine plants exhibiting the behaviors described here without there being something it is like to be a plant. So complex behavior doesn't necessarily shed light on whether a system is conscious or not. We can probe our intuitions about behavior from another angle by asking, does a system need consciousness to exhibit certain behaviors? For instance, would an advanced robot need to be conscious to give its owner a pat on the back when it witnessed her crying? Most of us would probably answer, not necessarily. At least one tech company is creating computerized voices indistinguishable from human ones. If we design AI that one day begins saying things like, "Please stop, it hurts when you do that," should we take this as evidence of consciousness or simply of complex programming in which the lights are off? We assume, for example, that an entirely non-conscious algorithm is behind Google's growing ability to accurately guess what we are searching for, or behind Microsoft Outlook's ability to make suggestions about whom we might want to CC on our next email. We don't think our computer is conscious, much less that it cares about us, when it flashes Uncle John's contact, reminding us to include him in the baby announcement. The software has obviously learned that Uncle John usually gets included in emails to Dad and Cousin Jenny, but we never have the impulse to say, "Hey, thanks, how thoughtful of you." It's conceivable, however, that future deep learning techniques will enable these machines to express seemingly conscious thoughts and emotions, giving them increased powers to manipulate people. The problem is that both conscious and non-conscious states seem to be compatible with any behavior, even those associated with emotion. So a behavior itself doesn't necessarily signal the presence of consciousness. Suddenly, our reflexive answers to question 1, what constitutes evidence for consciousness, are beginning to dissolve, and this leads us to question 2, regarding whether consciousness performs an essential function in, or has any effect at all on, the physical system that's conscious. In theory, I could act all the ways I do and say all the things I say without having a conscious experience of it, much as an advanced robot might, though admittedly it's hard to imagine. This is the gist of a thought experiment referred to as the philosophical zombie, which was made popular by David Chalmers. Chalmers asks us to imagine that any person could, in effect, be a zombie, someone who looks and acts exactly like everyone else on the outside without experiencing anything at all on the inside. The zombie thought experiment is controversial, and other philosophers, notably Daniel Dennett of Tufts University, claim that what it proposes is impossible, that a fully functioning human brain must be conscious by definition. But the conceivability of a zombie is worth contemplating if only in theory, because it helps us pin down which behaviors, if any, we think must be accompanied by consciousness. The goal here is to pry loose as many false assumptions as possible, and this particular mental exercise is useful whether or not a zombie is compatible with the laws of nature. Imagine that someone in your life is in fact an unconscious zombie or an AI. It could be anyone from a stranger behind a store counter to a close friend. The moment you witness behavior in this person that you think must coincide with an internal experience, ask yourself why. What role does consciousness seem to play in his behavior? Let's say your zombie friend witnesses a car accident, looks appropriately concerned, and takes out his phone to call for an ambulance. Could he possibly be going through these motions without an experience of anxiety and concern? Or without a conscious thought process that leads him to make the call and describe what happened? Could all this take place even if he were a robot, without a felt experience prompting the behavior at all? I have discovered that the zombie thought experiment is also capable of influencing our thinking beyond its intended function. Once we imagine human behavior around us existing without consciousness, that behavior begins to look more like many behaviors we see in the natural world that we've always assumed were non-conscious, such as the obstacle-avoiding behavior of a starfish, which has no central nervous system. In other words, when we trick ourselves into imagining that people lack consciousness, we can begin to wonder if we're in fact tricking ourselves all the time when we deem other living systems, climbing ivy, say, or stinging sea anemones, to be without it. We have a deeply ingrained intuition, and therefore a strongly held belief, that systems that act like us are conscious, and those that don't are not. But what the zombie thought experiment makes vivid to me is that the conclusion we draw from this intuition has no real foundation. Like a 3D image, it collapses the moment we take our glasses off. 3. Is consciousness free? As we go about our daily lives, we experience what appears to be a continuous stream of present moment events. Yet we actually become conscious of physical events in the world slightly after they have occurred. In fact, one of the most startling findings in neuroscience has been that consciousness is often the last to know. Visual, auditory, and other kinds of sensory information move through the world and our nervous system at different rates. The light waves and sound waves emitted the moment the tennis ball makes contact with your racket, for example, do not arrive at your eyes and ears at the same time, and the impact felt by your hand holding the racket occurs at yet another interval. To complicate matters further, the signals perceived by your hands, eyes, and ears travel different distances through your nervous system to reach your brain. Your hands are a lot further away from your brain than your ears are. Only after all the relevant input has been received by the brain do the signals get synchronized and enter your conscious experience through a process called binding, whereby you see, hear, and feel the ball hit the racket all in the same instant. As the neuroscientist David Eagleman puts it, your perception of reality is the end result of fancy editing tricks. The brain hides the difference in arrival times. How? What it serves up as reality is actually a delayed version. Your brain collects up all the information from the senses before it decides upon a story of what happens. The strange consequence of all this is that you live in the past. By the time you think the moment occurs, it's already long gone. To synchronize the incoming information from the senses, the cost is that our conscious awareness lags behind the physical world. Surprisingly, our consciousness also doesn't appear to be involved in much of our own behavior, apart from bearing witness to it. A number of fascinating experiments have been conducted in this area, and the neuroscientist Michael Gazzaniga describes some of them in detail in a wonderful chapter aptly titled "The Brain Knows Before You Do," in his book, The Mind's Past. Some of these experiments, most famously conducted by Benjamin Libet at the University of California, San Francisco, show that your brain prepares a complex motor movement of your body before you are consciously aware of deciding to move. In such experiments, subjects watch a special clock and, according to an instrument similar to the second hand on a traditional clock, mark the exact moment they decide to move, a finger, for instance. But using EEG, researchers can reliably detect the cortical activity signaling these impending movements about half a second before subjects feel they make the decision to move. More sophisticated versions of these experiments have been conducted since, producing the same results. Though it's not clear how these types of simple motor decisions relate to more complex decisions, like choosing what to eat for lunch or deciding between two job offers, there is no question that modern neuroscience is providing us with a quickly evolving view of the human mind. We now have reason to believe that with access to certain activity inside your brain, another person can know what you're going to do before you do. Our intuition that consciousness is behind certain behaviors is informed by our experience of freely making choices in the world, as our willed actions are inextricably linked to a sense of conscious control in the present moment. Whether it's as minor a decision as choosing water over orange juice, or as consequential as taking the job in Texas instead of the one in New York, we feel strongly that consciousness is required for the thought processes, and even the preferences, involved in making a decision. Consequently, findings about how decisions are made at the level of the brain, and the milliseconds of delay in our conscious awareness of sensory input, and even of our own thoughts, have caused many neuroscientists, Gazzaniga included, to describe the feeling of conscious will as an illusion. Note that in such experiments, the subjects felt they were making a freely willed action that in actuality had already been set in motion before they felt they made the decision to move. The argument that conscious will is an illusion is further strengthened by the fact that this illusion can be intentionally triggered and manipulated. Experimenters have been able to cause a feeling of will in subjects when the subjects, in fact, had no control. It seems that, under the right conditions, it's possible to convince people that they have consciously initiated an action that was actually controlled by someone else. A series of such studies were conducted by the psychologists Daniel Wegner and Talia Wheatley. Wegner explains, "We have a participant in the experiment put their hands on a little board that's resting on top of a computer mouse, and the mouse moves a cursor around on a screen. The screen has a variety of different objects, pictures from the book I Spy, in this case little plastic toys. Also in the room is our confederate. Both of them have headphones on, and together they are asked to move the cursor around the screen and rest on an object every few seconds, whenever music comes on. Most of the time, they hear sounds over the headphones they're wearing, and some of these are names of things on the screen. The key part of the experiment occurs when, in some trials, the confederate is asked to force our subject to land the cursor on a particular object, so the person who we're testing hasn't done it, but has been forced. It's just as though someone was cheating on a Ouija board. We play the name of the object to our participant at some interval of time before or after they're forced to move, and we find that if we play the name of the object just a second before they're forced to move to it, they report having done it intentionally. The feeling of agency can be fooled, and yet we go about our daily lives feeling the opposite. So what role does consciousness play if it's not creating the will to move, but merely watching the movement play out, all the while under the illusion that it is involved? We can see how the feeling of free will, as we typically experience it, is not as straightforward as it seems. And if we dispel this common notion, we can begin to question the idea that consciousness plays an integral role in guiding human behavior. It's important to clarify that when I talk about the nature of free will in this context, I'm referring specifically to the feeling of a conscious will. I'm pointing to the fundamental, day-to-day illusion we all seem to walk around with, that we are distinct and separate selves, separate not only from those around us and from the outside world, but even from our own bodies, as if our conscious experience somehow floats free of the material world. For example, like everyone else, I have the absurd tendency to regard my body, including my head and my brain, as something my conscious will inhabits, when in fact everything I think of as me is dependent on the functioning of my brain. Even the slightest neural changes, via intoxication, disease, or injury, could render me unrecognizable. Yet I can't seem to shake the false intuition that I could even choose to leave my body if I could only figure out how, and everything constituting me would somehow remain magically intact. It's easy to see how human beings across the globe, generation after generation, have effortlessly constructed various notions of a soul and descriptions of life after death that bear a striking resemblance to life before death. The brain as a system does have a type of free will, however, in that it makes decisions and choices on the basis of outside information, internal goals, and complex reasoning. But when I discuss the illusion of conscious will here, I'm speaking of the illusion that consciousness is the will itself. The concept of a conscious will that is free seems to be incoherent. It suggests that one's will is separate and isolated from the rest of its environment, yet paradoxically able to influence its environment by making choices within it. I was once at an event where my friend and meditation teacher, Joseph Goldstein, was asked if he believed we have free will. He answered the question with arresting clarity when he said that he couldn't even figure out what the term could possibly mean. What does it mean to have a will that is free from the cause and effect relationships of the universe? As he gestured with his hands dancing above him in the air, trying to point to this imaginary free will, he asked, "How can we even try to picture such a will floating about?" Many people, however, object on ethical grounds to the assertion that conscious will is an illusion, holding that people should be held responsible for their choices and behavior. But people can and should be held responsible for their actions, for a variety of reasons. The two beliefs are not necessarily contradictory. We can still acknowledge the difference between premeditated, lucid actions and the sort that are caused by mental illness or other disorders of the mind-brain. Imagine we're in a future city and a self-driving car hits a pedestrian, The response to this unfortunate event would depend on why the car didn't stop. If it turns out its software is flawed and can't detect pedestrians when they are bundled up in dark winter coats, for instance, that would require one response. If the car's sensors malfunctioned due to a defect specific to that one particular car, that would require a different response. And if the car hit the pedestrian because it was avoiding colliding with a crowded bus and pushing it into oncoming traffic, we would view this situation and respond to it very differently from the first two scenarios, as a success of the car's advanced technology rather than a flaw. Simply knowing that a self-driving car hit a pedestrian isn't enough information to help us stop this car from becoming a repeat offender, or to learn how to build better cars. It's important to notice that in these reflections about self-driving cars, consciousness never entered the conversation. And the brain can be viewed in an analogous way when it comes to conscious will. Knowing why someone behaved violently, for instance, will always be relevant. There are a range of human behaviors that can be influenced by deterrence, negative consequences, and empathy, along with inculcating the developing brains of children with self-regulation and self-control, and all the other methods civilized societies use to keep human beings generally well-behaved. The brain continually alters its behavior in response to input. It also changes and develops through memory, learning, and internal reasoning. With proper guidance, we eventually stop collapsing onto the floor and pounding our fists when we don't get our way. We couldn't accomplish this without concepts such as responsibility, accountability, and consequences. But in situations in which the usual civilizing pressures are powerless, when someone is suffering from schizophrenic hallucinations, for instance, it makes sense to treat that person and his behavior differently from someone subject to those pressures. Similarly, understanding the intentions behind violent behavior gives us relevant information about what kind of software someone's brain is running. A person who plots multiple murders has a brain that is operating very differently from someone who has a stroke while driving and accidentally kills a number of people. It may seem paradoxical to talk about ethics in this framework, because consciousness is essential to ethical questions. As a domain that pertains to suffering, all conversations about ethics are about how something feels. But in terms of the brain being a physical processing system, some of its goals can be ethical in nature, namely minimizing the number of events that cause suffering. And here our brains are analogous to the self-driving cars mentioned earlier. Even though we are talking about modifying a conscious experience, consciousness itself isn't necessarily controlling the system. All we know is that consciousness is experiencing the system. It is no contradiction to say that consciousness is essential to ethical concerns, yet irrelevant when it comes to will. A distinction between the brain's intentional behaviors and behaviors that are caused by brain damage or other outside forces against one's will is valid and necessary, especially when structuring a society's laws and criminal justice systems. But the claim that conscious will is illusory still stands, in the sense that consciousness is not steering the ship, and can be maintained alongside these other distinctions of intentionality and responsibility. The experiments described in this chapter are in fact not necessary to prove the point. Our experience alone reveals the illusion, and you can gain insight into this with a simple experiment. Sit in a quiet place and give yourself a choice, to lift either your arm or your foot, that must be made before a given time, before the second hand on the clock reaches the 6, for example. Do this over and over again and observe your moment-to-moment experience closely. Notice how this choice gets made in real time and what it feels like. Where does the decision come from? Do you decide when to decide? Or does a decision simply arise in your conscious experience? Does a free-floating conscious will somehow deliver the thought, move your arm? Or is the thought delivered to you? What actually made you choose arm over foot? It may suddenly seem that you, meaning your conscious experience, didn't have any part in it. It seems clear that we can't decide what to think or feel any more than we can decide what to see or hear. A highly complicated convergence of factors and past events, including our genes, our personal life history, our immediate environment, and the state of our brain, is responsible for each next thought. Did you decide to remember your high school band when that song started playing on the radio? Did I decide to write this book? In some sense, the answer is yes, but the I in question is not my conscious experience. In actuality, my brain, in conjunction with its history and the outside world, decided. I, my consciousness, simply witnessed decisions unfolding. 4. Along for the ride. Another wellspring of examples that turn our intuitions upside down and challenge the typical notion of free will can be found in the study of parasites and how they affect the behavior of their hosts. Toxoplasma gondii is a microscopic parasite that can infect all warm-blooded animals, but can sexually reproduce only in the intestines of a cat. While it can survive in any mammal, it must eventually make its way back to a feline to complete its life cycle. Toxoplasma most commonly infects rats because they frequent many of the same hangouts as cats, and the parasite has evolved a brilliant and extremely creepy mechanism for overcoming the challenge of traveling from the rats, who have a deeply ingrained fear of cats, back to its reproductive home. By a neurological mechanism that scientists still don't completely understand, Toxoplasma affects the behavior of the infected rats, causing them to forsake their fear of cats and in many cases to walk or even run directly toward their enemy. Toxoplasma creates hundreds of cysts in the brain of its host, causing dopamine levels to rise. Dopamine is a neurotransmitter that plays a role in mediating powerful emotions such as desire and fear, which helps explain much of the behavior we see in mammals infected with the parasite. It's possible that these rats somehow feel that they are being manipulated against their will by an outside force, but it seems more likely that their neurochemistry is being altered, and thus their desires and fears change. They no longer feel afraid of cats and are now, in fact, drawn to them. Humans can become infected with the parasite in the same way other mammals can, by consuming the undercooked meat of infected animals, or by coming in direct contact with environments contaminated with cat feces, such as drinking water, garden soil, or litter boxes. And it turns out that Toxoplasma also has an effect on human brains. As the science journalist Kathleen McAuliffe reports on observations made by parasitologists, neurons harboring the parasite were making 3.5 times more dopamine. The chemical could actually be seen pooling inside infected brain cells. Toxoplasma can cause a variety of behavioral changes in humans and is thought to be a trigger for schizophrenia and other mental illnesses in many people. According to McAuliffe's reporting, people with schizophrenia are 2 to 3 times more likely to test positive for antibodies to the parasite than those who don't have the disorder. In her fascinating and amusing New York Times article, In Parasite Survival, Ploys to Get Help from a Host, Natalie Angier reports, when Jaroslav Flager of Charles University in Prague administered personality tests to 2 groups of people, one showing immunological signs of a prior Toxoplasma infection and the other not, infected men scored comparatively higher than uninfected men in traits like suspicion of authority and a propensity to break rules, while infected women ranked relatively higher than non-infected women in measures of warmth, self-assurance, and chattiness. There are countless examples of other parasites affecting the behavior of their hosts. A horsehair worm will cause an infected cricket, which would normally maintain a safe distance from large bodies of water, to race toward the nearest lake or stream. By releasing neurochemicals that mimic those of a cricket, the worm urges the cricket to plunge in just in time for the worm to participate in mating season, which must take place in the water. Similarly, although pillbugs usually hide out during daylight hours to avoid being eaten by birds, those that are infected with the thorny-headed worm want nothing more than to venture out for a nice afternoon of sunbathing, on a light-colored surface no less, where the high-contrast environment makes them easy to spot by birds flying overhead. The worms then hitch a ride back to the bird's digestive system to lay their eggs. The larvae of the Alcon blue butterfly have a surface chemistry that mimics chemicals found on the surface of at least 2 species of ant larvae, causing the ants to carry the familiar scented butterfly larvae back to their nest to feed and nurture them, often at the expense of their own offspring. And parasitic wasps cause orb spiders to build webs that differ drastically from their usual design. After the wasp larva injects a chemical into the spider begins spinning a web much more suited to the larva's needs than its own, keeping the larva safe from nearby predators and providing the perfect netting for building its cocoon. The list goes on and on. When reviewing examples like these, we are immediately struck by how often we are blind to the complex array of forces at play in the behavior taking place all around us. One can't help but wonder what's truly driving all our own desires and personality traits, especially ones we tend to strongly identify with. There are also instances of bacterial infections causing behavioral changes in people, and scientists are continuing to discover links between infections and human psychological disorders. Streptococci bacteria, for instance, have evolved a defense mechanism enabling them to hide successfully from the immune system of children for some period. Molecules on the walls of their cells make them indistinguishable from tissues in the child's heart, joints, skin, and brain. Eventually, the child's immune system recognizes the strep as foreign to the body, but when it launches its attack, it may mistakenly target healthy tissues in the body as well. According to studies at the National Institute of Mental Health, in these cases, some cross-reactive anti-brain antibodies may target the brain, causing OCD, tics, and the other neuropsychiatric symptoms of PANDAS, pediatric autoimmune neuropsychiatric disorders associated with streptococcal infections. Here, the behavior of the host isn't supporting the goals of the parasite. Rather, the strep infection results in a phenomenon with unintended effects. But both types of examples uncover the same reality about our conscious experience. And the idea that I am the ultimate source of my desires and actions begins to crumble. With so many behind-the-scenes forces at work, from the essential neurological processes we previously examined to bacterial infections and parasites, it's hard to see how our behavior, preferences, and even choices could be under the control of our conscious will in any real sense. It seems much more accurate to say that consciousness is along for the ride, watching the show rather than creating or controlling it. In theory, we can go as far as to say that few, if any, of our behaviors need consciousness in order to be carried out. But at an intuitive level, we assume that because human beings act in certain ways and are conscious, and because experiences such as fear, love, and pain feel like such powerful motivators within consciousness, our behaviors are driven by our awareness of them and otherwise would not occur. However, it's now obvious that many behaviors we usually attribute to consciousness and think of as proof of consciousness could actually exist without consciousness, at least in theory. This brings us back to our 2 questions. And once again, it's hard to see how conscious experience plays a role in behavior. That's not to say that it doesn't, but it's almost impossible to point to specific ways in which it does. However, in my own musings, I have stumbled into what might be an interesting exception. Consciousness seems to play a role in behavior when we think and talk about the mystery of consciousness. When I contemplate what it's like to be something, that experience of consciousness presumably affects the subsequent processing taking place in my brain. And almost nothing I think or say when contemplating consciousness would make any sense coming from a system without it. How could an unconscious robot or a philosophical zombie contemplate conscious experience itself without having it in the first place? Imagine for a moment that David Chalmers himself is a zombie, completely lacking internal experience, and then consider the types of things he says in his book, The Conscious Mind, when explaining the concept of a zombie. Because my zombie twin lacks experiences, he's in a very different epistemic situation from me, and his judgments lack the corresponding justification. I know I am conscious, and the knowledge is based solely on my immediate experience. From the first-person point of view, my zombie twin and I are very different. I have experiences and he does not. I don't see how a system that isn't conscious would ever have cause to produce these thoughts, let alone how an intelligent system would be able to make sense of them. Without ever having experienced consciousness, there's no difference that the zombie Chalmers could be referring to. Chalmers' explanation for how a zombie is still conceivable in theory is that the language and concepts of consciousness could be built into the program of a zombie. A robot could certainly be programmed to describe specific processes like seeing yellow when it detects certain wavelengths of light, or even to talk about feeling angry under defined circumstances, without actually consciously seeing or feeling anything. But it seems impossible for a system to make a distinction between a conscious and unconscious experience in general without having an actual conscious experience as a reference point. When I talk about the mystery of consciousness, referring to something I can distinguish and wonder about and attribute or not to other entities, it seems highly unlikely that I would ever do this, let alone devote so much time to it, without feeling the experience I am referring to. For the qualitative experience is the entire subject, and without it I can have no knowledge of it whatsoever. And when I turn these ideas over in my mind, the fact that my thoughts are about the experience of consciousness suggests that there is a feedback loop of sorts, and that consciousness is affecting my brain processing. After all, my brain can think about consciousness only after experiencing it, one would presume. Other than this one sinkhole I often fall into, however, most of our intuitions about what qualifies as evidence of consciousness affecting a system don't survive scrutiny. Therefore, we must reevaluate the assumptions we tend to make about the role consciousness plays in driving behavior, as these assumptions naturally lead to the conclusions we draw about what consciousness is and what causes it to arise in nature. Everything we hope to uncover through consciousness studies, from determining whether or not a given person is in a conscious state, to pinpointing where in the evolution of life consciousness first emerged, to understanding the exact physical process that gives birth to conscious experience, is informed by our intuitions about the function of consciousness. 5. Who are we? When we talk about consciousness, we usually refer to a self that is the subject of everything we experience. All that we are aware of seems to be happening to or around this self. We have what feels like a unified experience, with events in the world unfolding to us in an integrated way. But as we have seen, binding processes are partly responsible for this, presenting us with the illusion that physical occurrences are perfectly synchronized with our conscious experience of them in the present moment. Binding also helps solidify other percepts in time and space, such as the color, shape, and texture of an object, all of which are processed by the brain separately and melded together before arriving in our consciousness as a whole. Sometimes binding processes become interrupted, however, due to neurological disease or injury, leaving the sufferer in a confusing world where sights and sounds are no longer synced, disjunctive agnosia, or familiar objects are seen for their parts but are unrecognizable, visual agnosia. Even with a healthy brain, we can sometimes catch small glitches in binding that shed light on the illusion it normally creates for us. A few months ago, I was walking to get a glass of water in the middle of the night when I heard a loud crash outside. For some reason, perhaps having to do with the fact that I was half asleep, I experienced the moment in an unusual way. I noticed my body's startle response before I heard the sound of the crash. For a brief instant, I felt myself responding to something that I had not yet heard. Imagine what your experience would be like if binding didn't take place at all. If, when playing the piano, for instance, you first saw your finger hit the key, then heard the note, and later finally felt the key hammer down. Or imagine if the process of binding were tampered with and you found yourself running before you heard the barking of the ferocious dog. Without binding processes, you might not even feel yourself to be a self at all. Your consciousness would be more like a flow of experiences in a particular location in space, which would be much closer to the truth. Is it possible to simply be aware of events, actions, feelings, thoughts, and sounds, all coming in a stream of awareness? Such an experience is not uncommon in meditation, and many people, myself included, can attest to it. The self we seem to inhabit most, if not all of the time, a localized, unchanging, solid center of consciousness, is an illusion that can be short-circuited without changing our experience of the world in any other way. We can have a full awareness of the usual sights, sounds, feelings, and thoughts, absent the sense of being a self who is the receiver of the sounds and the thinker of the thoughts. This is not at all at odds with modern neuroscience, an area of the brain known as the default mode network, which scientists believe contributes to our sense of self, has been found to be suppressed during meditation. There are other ways to suspend the sense of self. Psychedelic drugs, such as LSD, ketamine, and psilocybin, are known to quiet a circuit in the brain that connects the parahippocampus and the retrosplenial cortex in the default mode network, which explains why people describe losing their sense of self while under their influence. Scientists study the experiences people have on psychedelic drugs and their related brain activity through fMRI, functional MRI scans. While under the influence of these drugs, participants report experiences ranging from floating and finding inner peace to distortions in time and a conviction that the self is disintegrating. Many people assume that consciousness and the experience of self go hand in hand, but it is clear that in those moments when people report dropping the self, consciousness remains fully present. As Michael Pollan explains in his book, How to Change Your Mind, on the scientific research of psychedelics, the more precipitous the drop-off in blood flow and oxygen consumption in the default mode network, the more likely a volunteer was to report the loss of a sense of self. The psychedelic experience of non-duality suggests that consciousness survives the disappearance of the self, that it is not so indispensable as we and it like to think. Psychedelics also quell the communication among neurons in other areas beyond the default mode network, making activity in the brain less segregated in general. Aaron Brodwin, a science journalist, discusses the work of Robin Carhart Harris, who conducts imaging studies at Imperial College London on the impact of LSD on the brain. The separateness of these networks breaks down, and instead you see a more integrated or unified brain, Carhart Harris said. That change might help explain why the drug, LSD, produces an altered state of consciousness too. The barriers between the sense of self and the feeling of interconnection with one's environment appear to dissolve. Interestingly, one of the reasons people who take psychedelics inhabit such altered states is that this class of drug can also interrupt binding processes. It seems likely that this too contributes to a suspension of the feeling of being a self, distinct and separate from the world. Pollan points out that our sense of individuality and separateness hinges on a bounded self and a clear demarcation between subject and object. But all that may be a mental construction, a kind of illusion. Brodwin describes the experience of a participant in a study at Johns Hopkins on the therapeutic effects of psilocybin for patients with cancer and associated anxiety. For a few hours, he remembers feeling at ease. He was simultaneously comfortable, curious, and alert. More than anything else, though, he no longer felt alone. The whole you thing just kind of drops out into a more timeless, more formless presence, he said. Though it may be impossible for someone who hasn't experienced something like this to imagine it, consciousness can still persist without an experience of being a self, and even in the absence of thought. The journalist and author Michael Harris points out that it is partly because of this ability to interfere with one's sense of self that we know it is a construction. If the distinctness of the bodily self can be tampered with via such mechanical means, i.e. psychedelic drugs, a stroke, or a neurological disorder, then we must begin to accept that the bodily self, that feeling we are whole, inviolate beings, is not due to some special soul or I resident behind our eyes. As mentioned, the typical notion of self, along with other misperceptions of everyday experiences, can be overcome through meditation training, which is also now better understood at the level of the brain. For thousands of years, Eastern contemplative traditions have used meditation as an experimental basis for studying the nature of consciousness. And although Western science is a relative latecomer to these methods of introspection, research is now being conducted by neuroscientists on the specific effects of meditation on the mind and brain. This research will hopefully lead to new discoveries about how training our attention in systematic ways can provide a better understanding of consciousness and human psychology. At the very least, it confirms that valuable insights can be had through first-person tools of investigation. The Buddhist scholar Andrew Olensky describes the illusory nature of self that can be revealed through meditation. Like the flatness of the earth or the solidity of the table, it, the notion of self, has utility at a certain level of scale, socially, linguistically, legally, but thoroughly breaks down when examined with closer scrutiny. Regardless of whether or not one can break through the illusion of self, however, there is obviously a wide range of what is being perceived in any given conscious experience, from someone in a minimally conscious state to someone piloting an aircraft. One thing we can confidently state, no matter what is being perceived, is that either consciousness is present or it isn't. It's either like something or it's not. Just as we contemplated the moment at which conscious experience first appears in a developing embryo, we can wonder about the final moments of consciousness at the end of life. A friend of mine recently told me about spending time with his grandfather, who was slowly dying of heart disease. He described his grandfather's deterioration over the course of many months and the devastating experience of witnessing someone he knew well and loved dearly change so significantly. First to disappear was his grandfather's emotional regulation and impulse control, probably owing to damage occurring in his prefrontal cortex. His grandfather could no longer conceal his vacillating emotions, and everything he experienced, joy, frustration, lust, rage, was suddenly made known to everyone in the room. Next, his grandfather's memory began to fail, making the continuity of his personality less stable. Eventually, he lost the ability to speak and walk. At some point, my friend found himself wondering, as so many do in such situations, when his grandfather would truly no longer be there. When would his grandfather cease to be himself? And beyond that, when would his consciousness completely fade away? Sitting silently in a room without a recognizable personality and with most of his memories gone, his grandfather still seemed to my friend to be experiencing something. Even when only the slightest glow of awareness remains, consciousness is obviously present in some form up until the last moment it exists. And this minimal level of awareness, whatever it's like right before the lights go out altogether, may be completely unlike our familiar human experience. When Thomas Nagel asks us to imagine what it's like to be a bat, he is pointing out that we already know there are modes of consciousness vastly different from our own. Flying through space using echolocation must feel very different from walking down the sidewalk using vision, and the related mind-boggling study of sensory substitution, whereby scientists have been able to give blind and deaf people new methods for perceiving what most of us see and hear, provides evidence that there is in fact a wide range of potential experiences in a brain. For example, with a tool called the brain port, a small grid that sits on the tongue and converts a video feed into minuscule electric shocks, the brain can begin to learn to interpret electrotactile signals to the tongue. Using this technology, blind people can eventually accomplish tasks such as accurately throwing a ball into a basket and navigating an obstacle course. Using a brain port is obviously related to using vision to maneuver around the physical world, but what the actual experience is like must be very different from seeing with one's eyes. There is a wonderful term, Umwelt, introduced by the biologist Jakob von Uexküll in 1909, to describe the given experience of any particular animal based on the senses used by that organism to navigate its environment. Bats have one Umwelt, bees experience another, humans another, and someone using a technology like the brain port experiences yet another. David Eagleman is involved in research that explores the possibilities of expanding our human Umwelt to include information we don't currently have access to through our five senses. He explains that the brain doesn't care how it gets the information as long as it gets it. At a 2015 TED conference, Eagleman described the potential future results of sensory substitution, whereby new senses are created for people. There's really no end to the possibilities on the horizon for human expansion. Just imagine an astronaut being able to feel the overall health of the International Space Station, or for that matter, having you feel the invisible states of your own health, like your blood sugar and the state of your microbiome, or having 360-degree vision or seeing in infrared or ultraviolet. In fact, we know that the human brain, under the right conditions, can seamlessly integrate foreign objects into its map of what constitutes its body. The rubber hand illusion is an example of how, when certain conditions are met, an outside object can become included in one's conception of self. In the original experiment, the subject sits with his real hand underneath a table, while a rubber hand rests on the table in its place. When the experimenter strokes the subject's real hand and the rubber hand simultaneously with a brush, the subject begins to feel that the rubber hand he sees on the table belongs to him. Later versions of the rubber hand illusion have been demonstrated with the use of virtual reality. In one of these experiments, conducted by the neuroscientist Anil Seth and his team at the University of Sussex, the subject wears virtual reality goggles and experiences a virtual world in which she has a virtual hand. Sometimes the experimenters cause the hand to flash red in sync with the subject's heartbeat, and sometimes it is out of sync. As we would expect, the subject has a greater feeling of ownership of the virtual hand when the flashing is in sync with her heartbeat. Seth refers to our experiences of ourselves in the world as a kind of controlled hallucination. He describes the brain as a prediction engine and explains that what we perceive is its best guess of what's out there in the world. In a sense, he says, we predict ourselves into existence. The split brain phenomenon is also informative here, shedding light on both the malleability of consciousness and the concept of the self. Many people are now aware of the fascinating research conducted by Roger Sperry and Michael Gazzaniga at Caltech beginning in the 1960s on epilepsy patients who had undergone a corpus callosotomy. This is a surgical procedure in which the corpus callosum is cut, either partially or fully, separating connections between the left and right hemispheres of the brain in an effort to prevent seizures from spreading. Although these split-brain patients appeared surprisingly unchanged by the procedure, research on them revealed a bizarre and counterintuitive reality that calls into question many of our assumptions about the fluidity and boundaries of consciousness. In experiments on people who have undergone split-brain surgery, information can be given separately to each of their two brain hemispheres through vision, in the form of pictures, written language, etc., because the right visual field is projected to the left hemisphere of the brain and vice versa. In a normal person, the information coming through either visual field is shared with the opposite hemisphere of the brain through the corpus callosum. In split-brain patients, visual stimulus to each field is received by only one side of the brain. The same goes for stimuli presented to each ear, as well as for most of the information from patients' hands. For the most part, the touch receptors from each hand project to the opposite hemisphere of the brain, and the movement of each hand is also controlled by the opposite hemisphere. In fact, after surgery, split-brain patients can experience something called hemispheric rivalry, in which they are seen attempting opposing behaviors with their left and right hands in a disconcerting battle, such as trying to button up their shirt with one hand while the other hand is busy at work unbuttoning, attempting to hug a spouse with one arm while pushing him away with the other, and simultaneously opening and closing a door with opposite hands. Neuroscientists have developed a variety of creative methods for receiving communications from the two hemispheres of split-brain patients as well, revealing other startling aspects of the condition. In the vast majority of people, the left hemisphere is responsible for the expression of language through speech and writing, leaving the right hemisphere mute. However, the right hemisphere is able to communicate through nodding and gestures of the left hand, and singing in some cases. If a subject is given a coin to hold in her left hand without being able to see it, only the right hemisphere will be aware of it. When asked what she is holding, she will respond that she has no idea, because the left hemisphere, which maintains the ability to communicate verbally, has no awareness of the coin. But if asked to point to a picture of the object she was given, her left hand, controlled by her right hemisphere, the one that knows about the coin, will correctly point to the picture of a coin. Similarly, if the word key is presented to a subject's left visual field and he is asked what word he sees, he will report that he doesn't see anything. His speaking left hemisphere can't see the word. Yet if he's asked to pick up the object corresponding to the word that is up on the screen, he will reach out with his left hand, controlled by the right hemisphere, which sees the word, and pick up the key. This type of experiment can be repeated in a variety of ways, producing the same results time and again. In fact, split-brain patients sometimes report, via the speaking left hemisphere, that their left hand acts on its own, closing the book they are reading, for instance, a confirmation that they are unaware of the desires and intentions of the right hemisphere. To the surprise of the first neuroscientists to conduct such experiments, and to the rest of us, it seems that the same person can have two different answers to a question, along with completely different desires and opinions in general. And even more astonishing is the discovery that the feelings and opinions of each hemisphere seem to be privately experienced and unknown to the other. One self of a split-brain patient is as puzzled by the opinions and desires of the other as another person in the room would be. Whether or not both points of view in split-brain patients are conscious is difficult, if not impossible, to answer, but we have no reason to doubt that there is an experience associated with the thoughts and desires of each, and most neuroscientists believe that both hemispheres are in fact conscious. As the neuroscientist Christoph Koch of the Allen Institute for Brain Science points out, because both the speaking and the mute hemispheres carry out complex, planned behaviors, both hemispheres will have conscious percepts, even though the character and content of their feelings may not be the same.